Welcome to this short video on Azure OpenAI Center of Excellence or COE. With such huge interest in large language models and generative AI, organizations are wondering how to get started, what skills are needed, what use cases should they go after, how should they think about security, how should they think about the common concerns around privacy, leaking proprietary information, reliability, explainability of these models. And this is where COE comes into play. COEs are, of course, not a new concept. Think of COE as a group that is designed to help an organization navigate the complexity of working with an emerging technology such as generative AI. So while COEs are not new, the speed of change and frankly the disruption that's being caused by large language models and generative AI means that organizations need to think about generative AI or Azure OpenAI COE slightly differently. They need to think about outcomes. They need to think about an initial operating capability. They need to think about privacy concerns. So this video is designed to help organizations plan a center of excellence around Azure OpenAI service. Let us get started. Here's an overview of the topics that we'll cover as part of this video. We will start out with the background on generative AI and LLM concepts. We will talk about what is an Azure OpenAI COE. We will talk about the COE makeup. We will talk about some of the use cases that you can think about to get started. We will talk about this important topic of bringing together LLMs and combining them with your enterprise data. We'll talk about some toolkits, frameworks, and security, and then we will end this video with call to action. Let us get started. Let us talk about the key tenets of Azure OpenAI COE. The goal here is to understand the impact of generative AI and the disruption it's causing. The goal is also to conduct experiments within the applicable scenarios that apply to your organization, setting up guidelines for responsible and ethical use of generative AI, enhancing the understanding of fundamental principles behind generative AI across the organization, and then, of course, leading through innovation and creating significant business outcomes using large language models and generative AI. Let's talk about some of the LLM concepts, specifically concepts around GPT 4.0. Let's start with the diagram on the right-hand side of the slide. Let's look at the training. The training is comprised of three phases that are sequential in nature. The first phase is, of course, the pre-training phase, which is the computationally intensive phase. Here, you're training the transformer model on trillions of tokens. This includes data sets like the Wikipedia. Once you have conducted the pre-training, then you have to do supervised fine-tuning, and this is how you get the base model, followed by the reinforcement learning human feedback that turns this into an assistant model, the model that we are interacting with when we work with ChatGPT or GPT 4.0. Once the training is complete, we can talk about inferencing. And in inferencing, we are sending prompts to GPT-4. So what are prompts? Think of prompts as triggers for the model to generate some text or the output shown here on the slide. So with that diagram in mind, let's also talk about a couple of other things. So we have already talked about the prompts. Let's talk about fine-tuning a little bit. Fine-tuning is a process where the model is further trained on a specific data set to tailor its output. Fine-tuning enables us to customize the model for specific tasks. Let's also talk about the role of embeddings or embeddings in general. Embeddings in GPT-4 are numerical representations of words, so they can help the model understand the context and the semantic meaning of words, thus enabling them to generate relevant text. I've already talked about the base model. In case of GPT-4, you don't have access to the base model. What you have access to is the assistant model that I talked about. If you're interested in learning more about these concepts, I have additional video that covers some of these concepts in greater detail, and I encourage you to check that out. Let us talk about the makeup of the COE. It is always a good idea to have an executive sponsor that can ensure that you have the funding in order to be effective. The next thing you have to think about is the lead for the COE effort. And this person is going to be key. They're going to be leading you with your generative AI strategy. So it is important that this person not only understand the AI concepts, but more importantly, they need to understand the business domain. This is the person who's going to help you build the generative AI practice, have conversation with the business, interface with legal, and equally importantly, engage and encourage a community of practice around generative AI. In the past, COEs have not delivered to the expectations because COEs have often been thought of as an entity that is set up to tell you what to do. And given that generative AI is so new, I encourage that when you're setting up the COE, you also take on one or two concrete use cases in conjunction with developing guardrails for using generative AI. And if you're going to do that, you're going to need data scientists on your team. And when you have data scientists, you also need data engineers to support these data scientists. And then finally, if you're trying to spin up an Azure OpenAI service environment, you're probably going to need DevOps engineers who can provision your tenant, can provision the service, can provision vector databases and Kubernetes clusters, etc. Let us now talk about use cases. You're already familiar with the generic use cases that large language models are good at. If you've played with ChatGPT, you know that it is good at text summarization, QA, classification, text completion, etc. Our goal, of course, here is to take these generic use cases and then apply them to our domain. Let's look at a few examples to motivate this discussion. Let's talk about financial services. So here, let's consider some examples like the contact center analytics. Here, you're trying to summarize and extract key information from call logs in order to identify trends in customer complaints, perhaps. Let's talk about risk management. You're trying to recognize patterns and trends to identify risks through content, including social media. Let's look at process automation. Here you're trying to digitize documents, extract key information through semantic search, and then take that summarized information and take that next step in the workflow. Let's look at another example, healthcare. So in case of healthcare, you might want to use large language models for patient support. So here you're enabling a summary of patient conversation, so the doctor does not have to scroll through multiple screens to figure out all of the interactions they've had with the patient. Another example would be claims processing. So you're trying to automate the claims processing process by answering questions and providing information about patients, provider, about coverages, about deductibles. You may also want to do topic analysis. What do I mean by that? Well, you might want to mine web content for things like news, health news, or perhaps you're looking for drug recall notifications. Let's take a look at retail. So here you may want to do procurement management. So you're trying to extract valuable information, draw insights from vendor contracts. Perhaps you're trying to negotiate a discount based on the orders that you have placed. You may want to look at brand management. So you're connecting it to social media feeds, summarizing them, and doing some sort of a sentiment analysis. Let's look at manufacturing. Here, you may want to set up an internal help desk. And the idea here is to automate and to reduce resolution time for help desk tickets that your employees may have submitted. You may also want to take advantage of large language models for training. We know that they're good at question and answer. They're good at personalizing that interaction. You may want to use it for remote worker assistance. And the last example may surprise you. You have, I'm sure, heard of GitHub Copilot and most recently announced GitHub Copilot X. You may have also heard of companies like Complete.ai or BigCode. These are codecs that can assist you with code completion. And what we are finding is models like ChatGPT are good for developers in the sense that they can generate some prototype code, they can help you understand code, they can help you improve code. So these are some of the examples of how you can take the generic use cases that are supported by large language models and then apply them to your specific domain. Before we leave the slide, I also wanted to call out a video that I recently published that goes into greater detail about large language models applied to insurance. So if you're interested in that, I've provided the link on the slide here. Let us talk about leveraging large language models such as GPT-4 in the enterprise. What we are talking about here is taking the capabilities of GPT-4 and then enhancing them by combining it with enterprise data. And there are three patterns for us to consider here. The first one are the plugins. So think of plugins as something that connect GPT-4 to a third-party application. So these plugins enable GPT-4 to interact with APIs that may have been defined by developers, let's say to look up information from one of the business systems. The way it works is the following. Plugin developers expose one or more API endpoints accompanied with some manifest information and a description. This information is then provided to a model like GPT-4. So now when the user comes in and submits a prompt, language model is going to look at the prompt and may decide to invoke the API on behalf of the caller. The response of the API is then taken into account and a response is provided back to the user. So that's how the plugins work. Let's talk about another pattern called the retrieval augmentation generation. And even though the name sounds fancy, what this means is you may want to run a query against your internal system, maybe your knowledge repository, get some contextual information, and then provide that context as part of your prompt so that the language model can return an informed response back to the caller. And then finally, let's also talk about fine-tuning. We know that large language models are good at zero-shot or a few-shot learning, which means you can provide them just a few examples, and then they can learn from those few examples. If you don't want to provide these examples every time, you can also take advantage of something called fine-tuning, where you take a bunch of examples and you are tuning the model. So here's the process. You prepare and upload some training data. Then you train a new fine-tuned model, and then you start interacting with this fine-tuned model versus a base model like GPT-4. As good as these large language models are, they're not enough to complete complicated tasks that may require more information than what these models have been trained on. And this is where you need a notion of an orchestration layer that can help you call not just the language model, but also an external service. Another reason for using an orchestration layer is to understand that interaction with language models is stateless. So if you want to invoke these language models in succession, you may want to preserve the state. And this is where orchestration layer can come in handy. And we have great examples of orchestration layer. The semantic kernel, LangChain are great tools that you can use. In addition to the orchestration layer, you also see the advent of autonomous agents like AutoGPT, Baby AGI. Let's look at how the autonomous agents work. So let's say you have a high-level objective, and for example, you are trying to apply for a grant. Now you can use the power of large language model to break this high-level objective into smaller tasks. Perhaps you search for the grant, then you call an API to submit your application. So now you're going to use an agent to perform these tasks in order to accomplish this high-level objective. Then you evaluate the results of each of these tasks, and maybe you add new tasks or modify these tasks. And that's how an autonomous agent works. Let us talk about a pattern that was announced at Microsoft Build conference organized in May of 2023. Microsoft came out and talked about a blueprint for building enterprise applications using the large language model. What you see on the screen is the tech stack for a Copilot. If you start at the bottom of the screen, there's this AI infrastructure. Then you can have foundational models. This can be OpenAI models like GPT-4 or GPT 3.5. Alternatively, this could be open source models that you bring into the mix. On top of that is the orchestration layer, and we already talked about things like prompt flow, semantic kernel, LangChain. And then on top of that, you have your apps, which are using natural language processing to interact. So it's less about widgets and UI. And then they're also using the plugin extensibility to bring data from your business systems. So that's essentially the blueprint for a Copilot stack. The next topic that we want to talk about is security. Specifically, let's talk about data privacy. What types of data is being processed by Azure OpenAI service? Turns out that there are 3 types of data that we have to think about. First and foremost, prompts and the completions of those prompts. Second, training and validation data. You may want to fine-tune your models. And then finally, any log or metadata generated from the training process is another type of data that you have to think about. So first and foremost, an important statement that Microsoft is making as part of their documentation, that the customer data is never used to train, retrain, or improve the models in the Azure OpenAI service. In fact, Microsoft is hosting these OpenAI models within their Azure infrastructure. So no customer data that is being sent to Azure OpenAI service is in turn being sent to the OpenAI service under the covers. However, do keep in mind that Azure OpenAI service may store your prompts and completions for up to 30 days in order to monitor content and or behavior that may violate terms and conditions. Now we are going to talk about why they need to store it for 30 days in a moment, but I should add here that customers who have very specific use case may request Microsoft to modify the content filtering and abuse monitoring capabilities by submitting a request to Microsoft. Here's a diagram that I got from the Azure OpenAI service documentation page, and it talks about content management and abuse monitoring concepts that we talked about in the previous slide. So the Azure OpenAI service includes a content management system that works alongside the models to filter potentially harmful content. So the system works in the following manner. Both your input prompt and your completion are run through an ensemble of classification models that are designed to detect misuse. So if the system identifies harmful content, then your API call is going to get an error with an appropriate reason code. In addition to the synchronous content filtering that I just talked about, Azure OpenAI service stores prompts and completions from the service for up to 30 days in order to monitor the content and behavior that suggests the use of a service in a manner that may violate the terms and conditions of the service. Now that we understand the notion of content management and abuse detection, let us talk about where your data is retained and who controls your data. First and foremost, let's talk about fine-tuning data. This data is stored in Azure storage and is encrypted at rest using a Microsoft managed key. Let's also talk about the fine-tuned models that are also stored in Azure storage in the same region, encrypted at rest, and logically isolated within the Azure subscription and the API credentials. You can also take advantage of the customer managed keys so that you can encrypt data, such as data that you may have uploaded for fine-tuning using a customer managed key. And then finally, we already talked about prompts and completions, which can be stored for up to 30 days. Let us talk about some other considerations in addition to security that you have to think about when working with large language models. First and foremost, hallucinations. So large language models are prone to hallucinating, which means that they can generate text that may be factually incorrect or even nonsensical. Such hallucinations happen because large language models are trained on data that may be incomplete or contradictory. And as a result, they may learn to associate certain words or phrases with concepts, even if these associations are not accurate or don't make sense. So at the heart of it, a large language model is only interested in completing your document. It's interested in predicting the next sentence. And as we know, completing a sentence has many different options. And the training data set does not discriminate between fiction, fact, opinion, mistake, and that's how you lead to hallucinations. So how can you deal with hallucinations? First and foremost, you can provide the language models through the prompt an explicit instruction to only respond based on the context that you're providing. And we talked about the retrieval augmentation pattern earlier in this presentation. That's exactly that. The idea is you're providing the context and you're telling the language model to use that context in generating a response. Other idea that you've probably heard about is grounding, and this is what Bing Chat uses. It is using a connection to the internet to look up information beyond the knowledge cutoff that a language model may have. The final way in which you can deal with hallucinations is to pit one large language model against another. So you can ask the first language model a question, then you can take the response, frame it in a manner that validates the response from the first model, and use the second model essentially for validation. That's another approach to deal with hallucinations. Let's talk about the training bias, sort of similar to what we already talked about. These models have limitations. They might have been trained on inappropriate or biased content, which may reflect in the content that they are generating. The final challenge that you have to deal with is the model interpretability. And once again, based on the discussion that we had in the previous two bullets, you can assume that because the model can generate these sentences and it all depends on where it is getting started, the response is not interpretable, and this can be a problem in a high-stakes situation like medical diagnosis. And how do you deal with model interpretability? And here's a paper that I found quite interesting. Let me show you the link to this paper. It's called the Chat Graph, and it is using the power of large language models to extract the knowledge from the large language model, convert that into a knowledge graph, and then use validation against the knowledge graph to perform these interpretability decisions. With this, we come to the end of this video. Before I go, I wanted to give you a few things to think about as the key takeaways from this video. First and foremost, Center of Excellence is about enablement. It is about helping organization take advantage of this disruptive technology around generative AI and large language models. COEs are also about delivering outcomes. So traditionally, COEs have been around building guidance and guardrails, but I also want you to consider taking 1, 2, or 3 use cases and delivering them in a time-boxed manner. And through this work, you should be generating the best practices. COEs are also about fostering communities. It's about building knowledge around large language models and generative AI within your organization. And I hope you walk away from this video with this ability to take this power of LLMs and bring domain-specific use cases to your organization.